Hello chemistry fans, and welcome your faces back to Chemistry 1032 problem solving session here at the Academic Success Center at the Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. Chapter 10, Problem 5. In the following acid-base reaction, identify the acid, base, conjugate acid, and conjugate base for the following. Alright, so here's our equation. Again, let's play follow the atom. Nitrogen, 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 nitrogen. So if you want, you can just draw a quick arrow like that. Nitrogen, nitrogen. Well, here, the nitrogen has 3 hydrogens associated with it. Okay. Over here on the right, the nitrogen has 4 hydrogens associated with it. Wait a minute. That's important. 3 hydrogens on the left, nitrogen has, and now it has 4. So between here and here, it's gained a proton. It's received a proton. Nitrogen here to here has gained 1 proton going from left to right. So now that means that this nitrogen molecule must have been a base. Because remember, a base is a proton receiver or acceptor. So going from left to right, NH3 to NH4, the nitrogen must have gained or received a proton. That makes NH3 a base. Because nitrogen from left to right has received a proton. Left to right, proton receiver. Proton receiver is a base. Now, remember that acids and conjugate bases and conjugate acids and all that stuff, they all come together in pairs. So if you found the base, you found the conjugate acid. They always come in pairs. So this must be the conjugate acid. Remember, the conjugate acid is the molecule that forms once a base receives a proton. So this is a conjugate acid. Okay? Our base became a conjugate acid. After the base receives the proton, the molecule that forms is the conjugate acid. All right. Follow the atom. Oxygen, oxygen. So these two are connected. So here we have oxygen with 2 hydrogens. Over here, oxygen only has 1 hydrogen. 2 hydrogens on the left, 1 hydrogen on the right. So somewhere between here and here, water has donated a proton or lost a proton. 2 on the left, 2 hydrogens on the left, 1 hydrogen on the right. That makes water an acid. And you're probably thinking, wait a minute now. Previous questions, water has always been a base. Now you're saying it's an acid. Yes, I absolutely am saying that. Why? Because water has a dual role. Water can be an acid, depending on how you treat it. It can also be a base, depending on how it's treated. Water can do both. So don't be surprised if you see it doing both, because it can happily do both. Okay? So now, this is an acid, so this must be the conjugate base. Remember, a conjugate base is the molecule that forms after an acid has surrendered a proton. So the conjugate base here must be OH minus. Okay? Now I hope that finding the conjugate acid, conjugate base, acid and base, I hope that's become clear to you. If not, please don't hesitate to come and find your professor during office hours and ask for help. If you'd rather, just contact a tutor here at the Academic Success Center. That's a great idea. Please don't hesitate to do that. They're here to help you. But don't let yourself just slide by on this. This is a very important concept. I always test on it, always. I'm sure your professor does too. So it's worth some points on an exam. It also is very good for you to understand how acids and bases work for subsequent classes such as microbiology and physiology. All right, so now with that, I'd like to wish you good luck and good chemistry.